All right, hello once again, Jeff Scott of Rankin Technical College. And for the AWD1000 Web Development Technologies class, I've decided to do extra lectures on the last 6 chapters of our book, Murex, JavaScript, and jQuery 3rd edition. So far, I've done one extra lecture on Chapter 13, which was on how to work with numbers, strings, and dates. Now I'm moving up to Chapter 14 to talk about control structures, expressions, and regular expressions. About a 25 to 30 page chapter. We've talked about most of the stuff in here as far as equality and identity, break and continue, switch, conditionals, and inors, but we'll review them. Then there's an invoice application. I don't know in Mr. Gudmested's class if he's talked about exceptions. I have, but not much depth and breadth of coverage. So we will talk about those, and we will end up talking about regular expressions, because I may or may not forget, and I've given you a bunch of these already, but I'm going to say here for regular expressions, I would suggest if you want to learn all there is to learn about regular expressions, that you go out to regular expressions.info. Very, again, an ugly site, but unbelievably functional. This is that site, regular-expressions.info. All right? And what I like about this, not sure what that is not the fact that it's an ugly site, but when you look here, there's regular expression tutorials, and it also breaks it down by languages. So if I go to Tools and Languages, and I look down here, there's JavaScript. Using regular expressions with JavaScript, JavaScript's regular expression flavor, regular expression methods, how to use the regexp, replacement syntax, etc. This is very well done. So, I gave you the URL here, and you want the specifics on JavaScript. It's just /javascript.html. All right, let's jump into the chapter then. Now, the first thing that's talked about here is double equal versus triple equal. You may or may not be aware of this. So when I go over things like this, my intention is never, ever to demean or say, well, you know, your instructor probably didn't go over this, because I don't know if they did or not. All right, but I'm going to come in here. I'll make this about 28 should be good. And if I come through here and I say var x equals 0, var y equals double quote 0 double quotes, and then if I come through here and I say if if x equal y, that actually is done, and it comes out as what's referred to as true. Now, I don't know if they go into it in this book. I don't remember. We'll see it if they do. But JavaScript literally talks about values that are truthy, which is the word truth with a Y on the end, and falsy, which is like the word false with a Y on the end. All right? These are both falsy, and it's just saying basically is what's in here the same as what's in there. Now, if I change that to this, if x equal y, that comes out as false, because this is an equality only operator, and this is an equality plus identity operator. So not only does it check to make sure the values are the same, the triple equal sign checks to make sure that the types are the same. All right? All right. If I have a while loop, and I type in here while, in fact, let's create a loop control variable, var LCV for loop control variable equals 1. And I want to print out the values between 1 and 10. So I say y LCV is less than or equal to 10. And I do, let's say, a document dot write line. And I say LCV plus, and I'll put a BR tag there. All right. And then I say plus plus LCV. What that should do, is it should print out. In fact, let's leave the let's leave the BR tag out of there. We'll just put in a blank space. How's that? Space. That should print out 1 space, 2 space, 3 space, 4 space, 5 space, 6 space, 7 space, 8 space, 9 space, 10 space. It should do that. No problem. But if I come through there and I do this, all right, if I come through here and I put an if in here, and I say if LCV equals 7, break. All right. Now what's going to print out is it'll come through and it'll print out 1 space, 2 space, 3 space, 4 space, 5 space, 6 space. Then it's equal to 7, so it breaks out of the loop and it'll get me down to here. So that's all that will print. All right. So you've seen a couple differences. Now, if instead of this I put continue, then it'll print out 1, 2, 3, 4, 5, 6. It is 7, so it continues, which pushes it right back up here. Okay, I don't know if it'll do the plus plus or not. That's a good question. Let's change this to make it 0, and we'll do the plus plus LCV first. All right. Now it'll print 1, 2, 3, 4, 5, 6. Now it'll add 1 to it, which will make it 7. So it will come down. This will actually do this. That will skip the rest of the iteration. So 7 will not print. All right. So the idea is break gets you out of something. Continue gets you, skips the rest of that iteration and starts on the next iteration. All right. Now that's not exactly the explanation that they put in here, but that's the way I explain it. All right, switch. Not a bad example right here. A, well above average, B, above average, C, average, D, below average, F, failing, otherwise invalid grade. Okay? You'll notice that for each one of these cases that are in here, including the default case, we have a break on the end. That break is not mandatory right here. But let's say we left all the breaks out and the letter grade was an A. It would print this, then 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 it would print this. In other words, it would print out well above average, average, below average, failing, invalid grade. Because what the break does is it prevents what's called a fall through. So when it hits the break, so if it is an A, it prints this, it hits break, says get out of the switch. The value that's in here can be a number, and if it is, it should only be an integer. It can be a string. It can be a character. All right? It can be an expression. It can be a variable. On the bottom here, just so you are aware of this, the default is never, ever required, but it's always considered good practice to put that in. All right. How to use the conditional operator. Again, this is the way that I show it. All right. Maybe not the way your instructor shows it. Don't know. So I've just given you a bunch of examples in here. So let's put some code in that says var x equals 27, var y equals 38. All right, then we're going to have var max. And I put in here if x is greater than or equal to y, max equals x. Else, max equals y. Totally fine code. Absolutely nothing wrong with it. But I can rewrite it like this. X greater than or equal to y, question mark, meaning if that's true, x, colon, meaning if it's false, y. So I can rewrite these 1, 2, 3, 4, 5, 6, 7, 8 lines of code with just that. In fact, I'm incorrect. That's max equal. So this says check to see if x is greater than or equal to y. If it is, take x and assign it to max. If it's not, take y and assign it to max. Many people like to use this, and they use it for a lot of different reasons. All right, if you remember in the lecture, I think it was for the last chapter, where we said either there is 1 day left or there are 73 days left. And when you said is or are, that's an example of the way you could use that. All right. And again, I'm just giving you some information here. By no means am I trying to replace what's in the book. All right. Ands and ors. All right. I remember taking a class when I went for my 2-year degree that we had to take that was called, at the time we weren't called, we went from data processing to computer science to information technology. And it was so many years ago when I took the class, it was called DP, or data processing math. And then we had to sit there and talk about ands and ors and nots and things that were referred to as truth tables. All right. With an or, if this is true, or this is true, or they're both true, the thing becomes true. If this is, instead of an or, 2 pipe signs, if this was an and, 2 ampersands, this would have to be true, and that would have to be true. Now, if, for example, if this is a radio button, this says if you either click the California radio button or you click the North Carolina radio button. You really can't click them both because they're radio buttons. All right. The other thing, too, I'm going to give you a numeric example here. I think it's easier to work with that. Maybe you agree, maybe you don't, but either way, it's fine. Let's say here, var x equals 17, var y equals 21. Just arbitrary values. So, if x is greater than 10 and y is greater than 25, we want to do something. I don't know what. I'm just going to put a comment here that says, do something. Else, do something else. All right, well, let's check. Is x greater than 10? Yes. Is y greater than 25? No. Since this is an and, they both have to be true. So the if won't be true, so we'll do the else. With an and, they both have to be true. With an or, only one has to be true. Is x greater than 10? Yes. Is y greater than 20? It doesn't matter. We will do this. JavaScript, like many programming languages, also does what are referred to as short circuit operators. And what a short circuit operator means is if it's an or like this and the first one is true, you don't even have to check the second one. There's no sense in doing it. It's an or, you've got one true already, you do it. All right. On the other hand, if this was an and, it would have to check them both. But if this was an and this says greater than 18, well, that's false. Since that's false and they both must be true, we don't even check this one. So like most other programming languages, JavaScript does what's called short circuiting. It only does the checks it has to do. All right. Next is an invoice application. You can see it on your screen right here. The code to build that is shown right here. It calculates a discount amount and a total for an invoice. It uses conditional expressions to calculate different discount amounts depending on the type of customer you are. So the JavaScript is shown here on page 413. Hopefully you would agree with me that this pretty much is a case of very intuitive, let's just say, control structures. Regular customer, a loyal customer, an honored customer, and a default customer. If you're a regular customer and you bought less than $100 worth of stuff, you get no discount. If you're a regular customer, maybe you're just somebody who just logged on to this site, never has been there before, and you buy between 100 and less than 250, you get a 10% discount. 250 and less than 500, you get a 25% discount. Over 500 or over, you get a 30% discount. That's for a regular customer. If you have been saying you're a loyal customer, you always get a 30% discount. If you're an honored customer, all right, if you are an honored customer and you bought less than 500, you get 40%. Otherwise, you get 50%. You might look at some of those numbers and go, well, those are big discounts. Yes, they are. That said, you're going to get a bigger discount if you're a place like Walmart or Amazon because you buy in bulk. So notice here, it says use the subscript value or 0 if there wasn't anything. All right. Exceptions. As I always tell my students, an exception in real life is typically a good thing. An exception in programming is typically a bad thing. If I'm walking down the street, I've got a 18-month-old granddaughter, and let's just, I remember earlier this year taking her for a walk. She was over at my house, putting her in her stroller and taking her for a walk. Well, as we did it, night was falling, so we didn't go very far. It was kind of cool, but we didn't see anybody. But had we seen someone, and let's say we had passed another person on the road and they said, oh, wow, what an exceptional young lady, I would have probably said thank you. On the other hand, in programming terminology, an exception is an exception to the norm. All right? They shouldn't occur, so that's a bad thing. Typically, what you do is you take all of your code or whatever you want to do in your code that could possibly fail, and you put that in what's called a try block. If something in there fails, then you catch what made it fail. All right? So here's an example where we're using a calculate future value function. We're trying to do this, all right, but anything in here that could possibly fail will make this catch happen, and we'll just do an alert that says it'll give us an error message. That error message will say just that the function has thrown an error. So as the author says here, you can use a try-catch statement to process any errors thrown by an application. Errors are known as exceptions. The act of catching these exceptions is known as exception handling. You code the code in a try block that could possibly fail. You also can have a multiple number of exceptions. Now this is just a standard generic exception. The more specific the exception, the higher up it's got to go on here. But I could have as many exceptions as I needed to have. All right. Next, they actually talk about in here on 4.16 and 4.17 error objects. Some of the error types that you can run into, a range error. Maybe, for instance, I ask a person's age and it has to be between 1 and 125. All right? A reference error. So you've got in here int tax rate, you've never set it. A syntax error. A type error, where the type, you're expecting a number and you put something in there that's not a number. All right? Now you'll notice in here, this is the word throw. I always tell my students that the programming language throws errors, plural with an S. You, if you take control, you throw errors. So why would you throw an error? As they say right there, 2 reasons: to test your try-catch and to let the calling code know 1 or more arguments you tried passing in were invalid. Okay? Regular expressions I already mentioned to you a little bit. I showed you an excellent site for those. There are many different ways that you can use regular expressions. For instance, both these 2 statements do the same thing. This will find, if you are looking for something, does it contain the word Babbage? And Charles Babbage was a famous person in the IT world. So that says, does the pattern you're looking for contain the word Babbage? This would be true. This would be false. Ada Lovelace, she created basically the Ada programming language, is named after her. Many people consider her, yes, a female, to be the first computer programmer ever. All right, so you can run this, what's called a pattern test on here. So, as the author mentions here, on the bottom of page 418, a regular expression defines a pattern that can be searched for in a string. The pattern is stored in what's called a regular expression object. There's more that you can use on this than was shown right there. All right? It says how to match special characters. Here are some examples. Now, if you looked at some of my earlier, if you ever looked at some of my earlier tapes, one that I had done recently was I went through and set up a JavaScript, or set up an HTML5 form, basically stripped it of all of its JavaScript. Say that again. I created an HTML form, did not validate it at all using HTML, but rather validated it using JavaScript. So I did a lot of this stuff. And there's other ones that are not even shown here. All right. If you are creating your own expression pattern, this right here, the caret has 2 different meanings. If it's at the beginning of your expression, it means starts with. But if you've got it inside of an expression, it means or. I'm sorry, it means not. My fault. The $sign typically appears at the end of a regular expression, and it means ends with. You can have what are called repeating patterns. This is one of the ones that I tend to use quite a bit right here. This would be right here, for example, for a phone number. In fact, I guess it's this one. All right. It says 3 digits, a dash, 3 digits, a dash, and 4 digits. There is another very good site that I have pushed my students at. This, again, is an unbelievably simplistic site, but just to show you, it's html5pattern.com. Doesn't look like much, but for example, phones. You click there, and There's a phone number. All right, and they show you different ways. Here's the USA phone number right here. And the pattern that you end up getting here is essentially the same one that was just shown in the book. That one right there. The \D means digits. 3 means 3 digits. That means followed by a hyphen, followed by 3 digits, followed by a hyphen, followed by 4 digits. All right. Sometimes the best way to find this out, let's say that I wanted, here I'm going to put in here, JavaScript phone number validation. All right. And sooner or later, it's going to push me back to W3 Schools, but I won't even look there. This is w3resource.com. All right. And they've got different types of validation in here. There's all sorts of different ones that you can look online for this information. Okay. All right. Regular expressions for data validation. Here are some of the ones like I mentioned right there. There's a phone number. There's a credit card. There's a zip code. The zip code is interesting. This says 5 digits, and then notice the rest is in parentheses, which means 5 digits and optionally a dash and 4 more digits. Now, this is kind of a misnomer here. It says a pattern for testing dates to make sure they're in month, day, year format. That will do that. The author is 100% correct right there. But if you put in 27 for the month number, that will not catch it. So you'll have to put in more code to make sure that indeed what you're putting in here is what you want to be searching for. All right, the chapter ends with this account profile application, another data validation. But we're not checking to just make sure something is there. Notice with the email, we're trying to make sure that it's a valid email. All right. For a phone number, we're trying to make sure it's in the right format. For a zip code, we're making sure it's in the right format. With a date of birth, we're making sure it's in the right format. All right. And you'll notice that when we look at the JavaScript for it, what do we have? Notice how with the dates, they're checking the months, and all they're checking in here is they're saying if it's less than 1 or it's greater than 12, it's bad. If the day is greater than 31. So in other words, I believe the example they have here, if you put in February 31st, all right, it would come back and say that it was a valid date. Now, years ago, I had my students, I was at a different college, I had them take this example or one like it and explode it to check valid dates, including leap years. It's a lot of code. Not a warning, just telling you, it's a lot of code. The email test, there are many books that will tell you don't even make an email test because there's so many different ways that emails can be done, but this is the one they've used. There's the phone number. There's the zip code. Okay? And that's it for this chapter. So, we look quickly at the summary here on page 431. The identity operator, remember, 3 equal signs or an exclamation point, 2 equal signs, checks both the value and the type. The break statement jumps you out of wherever you are and ends. It's typically in a loop. The continue statement passes. It goes past it. It skips the rest of that iteration. It starts on the next iteration. A switch statement allows you to have cases, including an optional default case. Always put a break at the end. The conditional operator is also called the question mark colon operator. And you put in a test, and if the test is true, what you put in after the question mark, you do. If it's not true, and what comes in after the colon, you do. It is even possible to nest those. All right? And an OR Remember with an and, if I say if x and y, x must be true and y must be true. If x is false, because short circuiting is used by JavaScript, if x is false, you never even check y. If you say if x or y, either one or both have to be true. So if x is true and it's an or, you don't check y because you don't have to. Exceptions are exceptions to the rule. You do exception handling in JavaScript much like you do it in many other programming languages through the use of a try-catch statement. So you put in code in a try block that could fail, and in the catch, you catch it so you can handle it the way you want it to be handled. Regular expressions define patterns you can search for. And one of the ways you can do that is to use the test method. That's it for this chapter. Come back and do one more, Chapter 15, and that is a little longer, but it's on how to work with browser objects, cookies, and web storage. So I'll be back with that in just a couple minutes.